Golden Iris Productions presents Quantum Gravity, the Quantum World.
In electromagnetism, new constants define the strength and structure of interactions: epsilon naught, mu naught, 4 pi, 8 pi, c, and c squared. These constants connect electric and magnetic fields, determine the strength of Coulomb forces, and even define the speed of light through the equation c equals 1 divided by the square root of epsilon naught times mu naught. Our next step begins with Coulomb's law, the electromagnetic analogue of Newton's gravitational law, and opens the door to the physics of charge, fields, and quantum interactions. In gravity, a different set of constants defines the strength and structure of interactions: g, c, 8 pi, and lambda. Here, g sets the strength of gravitational attraction, c again links space and time, and lambda introduces a new scale associated with the energy of empty space. Just as epsilon naught and mu naught organize electromagnetism, these constants shape the geometry of spacetime and the dynamics of gravitational fields.
Electromagnetism and gravity each rely on their own constants, but combining quantum mechanics with gravity requires something deeper. The familiar constants g, c, and h bar can be merged to form new fundamental scales: Planck length, Planck time, and Planck energy. These scales mark the boundary where classical space-time breaks down and quantum effects of gravity become unavoidable. This chapter explores how new constants and new symmetries must emerge to describe space-time itself as a quantum object. Newton's gravitational law and Coulomb's electric law share the same structure. F sub g equals g times m1 times m2 divided by r squared. F sub em equals k times q1 times q2 divided by r squared.
Both forces weaken as 1 over r squared because their influence spreads over the surface of a sphere whose area grows as 4 pi r squared. Gravity depends on mass and is always attractive. Coulomb's force depends on charge and can be attractive or repulsive. The constants differ enormously. G is tiny, while k equals 1 divided by 4 pi epsilon naught is large.
Yet the mathematical form is identical. F equals constant times source 1 times source 2 divided by r squared. This shared structure is a clue that geometry shapes the laws of physics.
In Newton's law of gravitation, the constant g is extremely small. It scales down the enormous masses of the universe so that gravity has the observed very weak strength. F sub grav equals g times m1 times m2 divided by r squared. In Coulomb's law, the constant k equals 1 divided by 4 pi epsilon naught is extremely large. It scales up the tiny electric charges so that electric forces become measurable. F sub elect equals k times q1 times q2 divided by r squared. Both laws share the same inverse square structure.
The factors 4 pi and 8 pi arise from geometry. A point source spreads its influence over the surface of a sphere, whose area is A equals 4 pi r squared. This is why Coulomb's constant contains 4 pi, reflecting the geometry of field lines spreading through space.
In Einstein's field equation, g sub mu nu equals 8 pi g times t sub mu nu, the factor 8 pi comes from the same spherical geometry combined with the mathematics of curvature. Both constants encode the geometry of how fields spread through spacetime.
The gravitational constant is extremely small. G equals 6.674 times 10 to the power negative 11 Newton meters squared per kilogram squared. Coulomb's constant from K equals 1 over 4 pi epsilon naught is enormous. K equals 8.988 times 10 to the power 9 Newton meters squared per Coulomb squared.
The elementary charge is tiny but fundamental. E equals 1.602 times 10 to the power negative 19 coulombs. These constants define the strength of electric and magnetic interactions and determine the speed of light. C equals 1 over the square root of epsilon naught mu naught.
Electromagnetic fields and gravity. Individual charged particles generate extremely strong electric and magnetic fields that extend over large distances. These fields are far stronger than gravity by many orders of magnitude. However, in ordinary matter, positive and negative charges occur together. Their fields superpose and largely cancel when viewed from far away. This cancellation neutralizes the net force, but the underlying fields remain present and active within the material.
A neutral atom illustrates this clearly. The proton's outward electric field and the electron's inward electric field cancel at large distances, producing no net external force. Yet inside the atom, these fields are enormous. They bind electrons, shape chemical bonds, and determine the structure of matter. Neutrality means the forces cancel, not that the fields vanish. The fields are still present and still govern the physics of the system.
In matter, electric and magnetic fields from individual charges can be extremely strong, yet their forces largely cancel in aggregate, leading to overall neutrality. The fields remain present even when the net force is nearly zero. These same fields are governed by a small set of constants: epsilon naught, mu naught, E, 4 pi, and C.
The origin of G. The question: could the gravitational constant G somehow emerge from these very same quantities and the collective behavior of electromagnetic fields, rather than being a completely independent constant of nature?
Einstein's field equation contains a geometric factor. G sub mu nu equals 8 pi g times T sub mu nu. Coulomb's law constant contains a related factor. K equals 1 divided by 4 pi epsilon naught. Both arise from the surface area of a sphere, 4 pi r squared.
If electromagnetism and general relativity share deep geometric structure, then one may ask, G is approximately equal to 8 pi divided by epsilon naught times mu naught times q squared. All of the constants that define light, charge, and the electromagnetic vacuum already appear. Could gravity be an emergent coupling arising from the same vacuum fields that govern electromagnetism?
Electromagnetism defines its fundamental coupling through Coulomb's law. F equals 1 divided by 4 pi epsilon naught multiplied by q squared divided by r squared. The electric constant K equals 1 divided by 4 pi epsilon naught sets the strength of the interaction. If gravity is emergent, its coupling should be constructible from the same vacuum constants.
Einstein's field equation introduces a universal geometric factor. G sub mu nu equals 8 pi g times T sub mu nu. To compare electromagnetism with gravity, we recast Coulomb's coupling in an 8 pi form. 1 divided by 4 pi epsilon naught becomes 1 divided by 8 pi epsilon naught. This aligns the electromagnetic coupling with relativistic spacetime geometry.
The electromagnetic vacuum is defined by two constants,
c squared equals 1 divided by epsilon naught times nu naught. Multiplying by c squared brings in the magnetic structure of the vacuum. Gravity now appears not as a force, but as a coupling built from vacuum properties.
Rearranging the electromagnetic coupling and vacuum constants yields a structure of the form G is proportional to 8 pi divided by epsilon naught times mu naught times q squared. The geometry of general relativity and the constants of electromagnetism now appear together. No new physics has been added.
From the speed of light, c squared equals 1 divided by epsilon naught times mu naught. This introduces the magnetic structure of the vacuum. But gravity does not couple to fields, it couples to energy density. The energy density of the electromagnetic vacuum is U equals 1/2 times open parenthesis epsilon naught E squared plus B squared divided by mu naught close parenthesis. A second factor of 1 divided by mu naught converts the coupling from field strength scaling to vacuum energy scaling.
From Coulomb's law, Einstein's geometry, and the electromagnetic vacuum constants, we are led to a coupling of the form G is proportional to 8 pi divided by epsilon naught times mu naught squared times q squared. This expression contains the geometric factor 8 pi, the constants epsilon naught and mu naught, and the fundamental unit of charge, q. No new physics has been introduced, yet this is still not Newton's constant. We now compare G measured equals 6.67430 times 10 to the power negative 11 meters cubed per kilogram per second squared, with the electromagnetic form G form equals 8 pi divided by epsilon naught times mu naught squared times q squared. Their ratio defines a single missing factor. R naught squared equals G measured multiplied by epsilon naught times mu naught squared times q squared divided by 8 pi. All disagreement is absorbed into one squared length.
From the comparison, G measured equals 8 pi divided by epsilon naught times mu naught squared times q squared multiplied by the missing factor. We define R naught squared equals G measured multiplied by open parenthesis epsilon naught times mu naught squared times q squared divided by 8 pi close parenthesis. Substituting the measured constants gives R naught equals 9.76 times 10 to the power negative 37 meters. A fundamental microscopic length is extracted directly from gravity.
R naught equals 9.76 times 10 to the power negative 37 meters. R naught squared equals 9.53 times 10 to the power negative 73 square meters. This single squared length accounts for the entire weakness of gravity.
Substituting the extracted scale into the constructed coupling, G equals 8 pi times R naught squared divided by epsilon naught times mu naught squared times q squared. This gives G equals 6.67 times 10 to the power negative 11 meters cubed per kilogram per second squared. This matches the measured gravitational constant. All remaining physics is encoded in R naught.
The extracted scale is R naught equals 9.76 times 10 to the power negative 37 meters. Comparing with the Planck length, the Planck length equals 1.616255 times 10 to the power negative 35 meters. The new scale is not independent. It is set by the electromagnetic coupling and the Planck scale.
The Planck length sets the scale of quantum spacetime.
The fine structure constant sets the strength of electromagnetism. R0 equals alpha raised to the power 0.5706 times the Planck length. This links gravity's strength to both. This suggests that the weakness of gravity is not arbitrary, but emerges from the electromagnetic structure of the vacuum. Golden Iris Productions presents Chapter 2: Building Gravity. Building the structure of gravity.
Step 1. Coulomb's law. F equals 1 divided by 4 pi epsilon naught multiplied by q squared divided by r squared. Step 2. Relativistic vacuum. C squared equals 1 divided by epsilon naught times mu naught. This introduces magnetic structure.
Step 3. Geometry of space-time, from Einstein. 8 pi times g sub mu nu equals 8 pi g times t sub mu nu. Step 4. Vacuum energy scaling. Mu naught becomes mu naught squared. This ensures that energy density couples to curvature. The resulting structure is G is approximately equal to 8 pi divided by epsilon naught times mu naught squared times q squared. Step 5. Introduce the microscopic scale. G equals 8 pi times r naught squared divided by epsilon naught times mu naught squared times q squared. R naught equals 9.76 times 10 to the power negative 37 meters. Step 6. Relation to fundamental constants. R naught equals alpha raised to the power 0.5706 times the Planck length. Conclusion. Gravity's strength emerges naturally from the electromagnetic vacuum, linking Coulomb's law to vacuum energy, to Einstein geometry, to R naught squared, to G. Stepwise physical reasoning. 1. Coulomb's law, F equals q squared divided by 4 pi epsilon naught r squared, defines the fundamental electromagnetic coupling. 2. The relativistic vacuum, c squared equals 1 divided by epsilon naught mu naught, introduces magnetic structure and light propagation. 3. Einstein geometry, with 8 pi and g sub mu nu equals 8 pi g t sub mu nu, ensures the coupling matches spacetime curvature. 4. Vacuum energy scaling, mu naught becomes mu naught squared, ensures gravity couples to energy density, not just force. Result: G is approximately equal to 8 pi divided by epsilon naught times mu naught squared times q squared.
5. Compare to measured G. Everything else is fixed by physics. The only remaining factor is a microscopic length, R0. 6. Solve for R0. R0 squared equals G measured multiplied by epsilon naught times mu naught squared times q squared divided by 8 pi. 7. Link to fundamental constants. R0 equals alpha raised to the power 0.5706 times the Planck length. Rationale. Each constant appears for a physical reason. R0 is the unavoidable remainder. This is not curve-fitting. It is physically constrained by the electromagnetic vacuum and spacetime geometry.
We found R0 equals alpha raised to the power 0.5706 times the Planck length. What this means? The exponent 0.5706 is the precise factor that scales the Planck length to the microscopic gravitational scale R0. It shows that gravity is much weaker than electromagnetism. The factor less than 1 reflects the dilution of the electromagnetic vacuum energy into spacetime curvature.
Our journey. We started with Coulomb's law, the fundamental electromagnetic force.
We introduced the electromagnetic vacuum and light propagation, with c squared equals 1 divided by epsilon naught mu naught. We incorporated Einstein's geometric factor 8 pi in space-time curvature. We included vacuum energy scaling. Mu naught becomes mu naught squared for energy density coupling. Result: the form of G is constrained by known physics.
We extracted the microscopic scale from measured G. R0 equals 9.76 times 10 to the power negative 37 meters. We squared it to complete the coupling. We linked it to fundamental constants. R0 equals alpha raised to the power 0.5706 times the Planck length. This reveals gravity as an emergent effect of the electromagnetic vacuum. Takeaway: the strength and scale of gravity are naturally connected to electromagnetic and quantum constants.
We have traced the origin of gravity's strength from fundamental constants: epsilon naught, mu naught, q, c, and 8 pi. The only missing piece is a microscopic length scale, R0. This scale is not arbitrary. It connects directly to the fine structure constant and the Planck length. Science has a new clue about the origin of gravity.
Gravity may be an emergent effect of the electromagnetic vacuum. The weakness of gravity is quantitatively explained, not just assumed. A single microscopic scale, R0, links electromagnetism, quantum physics, and space-time geometry. This opens the door to unifying fundamental forces at a deep physical level. We may finally see gravity as part of the same vacuum that governs light and charge. From Coulomb's law to Einstein's equations, we followed a logical path. Nature gave us the missing scale R0, a window into quantum gravity. This shows that constants we once thought separate are deeply connected. It suggests new ways to explore spacetime, the quantum vacuum, and unification. This is a step towards understanding the universe at its most fundamental level.
To be continued.